Welcome to NIOS live classes. Subject Science and Technology. Class 10th. Book number 212. Module number 4 Energy. Lesson 13 Work and Energy. Part 1. Before starting our lesson, let's learn some difficult words for better understanding. First is force. It means a push or pull something. Next is displacement. It means moving from one place to another in any direction. Energy. Energy is the ability to do work. For example, for playing we need energy, and through food we get that energy. Next is power. It states that how fast work is done. Next is motion. It means the movement of an object, whether it is upward, downward, sideways or sloping, circular, etc. Next is perpendicular. Perpendicular is at a right angle with L shape. Next is gravity. Gravity is a force that pulls things to earth. Next is frictionless. It means no rubbing force, a very smooth surface. Next is conversion. It means changing from one form to another. Next is transformation. Transformation, it means the change of energy form, like chemical energy to mechanical, or chemical energy into light energy. And there are more, like electrical energy changes into light energy, etc. Conservation of energy, it means the energy cannot be created or destroyed by anyone or anyhow. Now our lesson which we are going to learn is work and energy. Introduction. In the previous lesson, we learned that force changes the motion of an object. Like here is a visual explanation on the scheme. An object at rest stays at rest. Then an object acted upon by a balanced force stays at rest. And then an object acted upon by an unbalanced force change speed and direction. Same as for the football, an object at rest stays at rest, and when it acted upon by an unbalanced force, it changes in speed and direction. When a force acts on an object, the object moves some distance, whether it is forward, backward, etc. For example, pulling a trolley bag, opening a gate, or pushing a trolley, so here we can see when force acts, there is a movement object happen, and this brings us to new ideas which is called work, energy and power. Here is a relation between the work, energy and power. When there is a force applied on a ball, it starts moving, so it means it has energy, so that's why it is moving. We use words work and energy in daily life, but science defines them differently. In this lesson, we will learn the scientific meaning of work, energy, and power. Work, energy, and power. They are interrelated with each other. For example, eating food is a work, and the energy we get from the food, then we do our work with the power we get from the food. We will also study the different forms of energy and how one form changes into another. For example, there is a solar panel which absorb the light energy and produce chemical energy. Through we get the mechanical energy. In short, we can say solar energy changes into mechanical energy. Same as thermal energy changes into electrical energy, etc. These changes follow an important rule called the law of conservation of energy. Sometimes we want work to be done faster. The speed of doing work is called power. But machines are usually rated by how much power they have. They are vary from human power, and it is measured in watts, kilowatts, or horsepower. Let's take a short break. Welcome back to our classes. Objectives. After completion this part, you will be able to understand and define work and its SI unit. And also can describe the types of work. Now the topic is 13.1 Work. Do you know what is work? Here is a picture on the screen which shows different activities doing by a human. Example, scientists reading their experiments, a boy is writing, there is a boy pulling the dumbbells and a boy breaking the rocks, etc. These all are we can call work. Basically, in daily life, we call activities like standing, reading, or lying down as work. For example, doing the laundry or after laundry, hanging them outside in the sunlight or ironing the clothes, or went for a shopping, doing yoga, makeup, or washing the car or wearing the clothes. These all are work. But in science, work has a special meaning, which is work is done only when a force is applied. Here is a scientific definition of work is force is applied and the object moves some distance in the direction of the force, then we can call that there is a work has been done. Here is a visual diagram of explaining the work. Force is applying forward on the box and box move forward. For example, pushing a red cement trolley forward, it includes both force and movement. There is a forward force has been used. And the second one, there is a boy pulling the arrow backward. Third one is there is a magnetism force which is generated by a magnet. Also in second line first figure, it states the gravitational force which is Earth's own force. Next is frictional force, and last but not least is acceleration force. In simple words, when a force acts upon an object causing a displacement in, it is called work. There are three types of work: positive, negative, and zero work. Let's explain it briefly. First is positive work. The work done is positive if the object moves in the same direction as the force applied. For example, pushing a ball forward and it moves forward, so there is a positive work. And also another example, when you move a chair, the work done in the forward direction, and so the chair moves forward. Next is negative work. If the displacement of the object is in the opposite direction of the applied force, then the work done is negative. For example, pushing a car on a slopy road, so then the force is forward but the movement is backward, so there is a opposite direction of force and work. And also, for better understanding, we can look at this example also, where all objects that are thrown up in the air are moving against the gravitational force. Thus, the work done is negative. Next is zero work. When the force applied and displacements of the objects are perpendicular to each other, then the work done is zero. Let's take a short break. Welcome back to our classes. We have learned that there is a third condition where work done is 0, and it has three conditions in it. First is if a force is applied but the object does not move, then work is 0. For example, pushing a wall does no work because the wall does not move. Same as holding a heavy suitcase or dumbbell in a fixed position, resisting the force of gravity but not moving it upwards or downwards, then there is no work has been done. And also pulling on a door handle that is locked where the bolt restricts any movement, then there is also a no work done. And second condition is if no force is applied and the object is at rest or moving with constant speed. For example, when a car moves on a flat road with constant speed, its speed does not change. Since there is no change in motion, then no net work is done on the car. And also a hockey puck on ice. After being struck, a puck on a frictionless surface would travel in a straight line at a constant speed forever. If the force and movement are at right angles to each other, in this case the work done is 0. This is our third condition, and its example is walking while carrying a bag. When you walk horizontally while holding a heavy suitcase, then the displacement has been up, forward, and the upward force. And also there is also other example, moving on a flat floor. A block moving on a smooth horizontal table is acted upon by gravity vertically, but it moves horizontally, so there is no work. The gravity force pulls the satellite towards the center of the earth, which is force direction, but the satellite is actually moving sideways along the circle, which is motion direction. So there is also no work. We have completed our part 1. Thank you for paying attention.